finger, and you just have your baby finger underneath. So sine 30 is square root 1 divided by 2, because there's only one finger underneath, which simplifies to a half. If we wanted sine 90 degrees, you'd bend down your 90-degree thumb, and so you have 4 fingers underneath. So sine 90 is square root of 4 divided by 2, which simplifies to 1. What would sine 60 be? Work out the answer and click here when you're ready to check. Did you get square root 3 divided by 2? For cos, we just count the fingers above instead of the ones below. So for cos 60, bend down your 60 finger and count the fingers above, 1. So cos 60 is square root 1 divided by 2, which simplifies to a half. What would cos 90 be? Work out the answer and click here when you're ready to check. Did you get 0 degrees? Bend down your 90-degree thumb and there are no fingers above. So root 0 divided by 2 is 0. And finally, tan. For tan, we still count fingers, but there is just one extra little twist. The same as for sine and cos, bend down the angle finger. So let's find tan 60. Let's bend down our 60-degree finger. We've got 1 cosine finger above and 3 sine fingers below. For tan, we flip our hand over and we have 3 sine fingers above and the 1 cosine below. So tan is square root fingers over square root fingers. So square root 3 over square root 1, which simplifies to root 3. What would tan 30 be? Work out the answer and click here when you're ready to check. Did you get square root 1 divided by square root 3, which would simplify to 1 over root 3? So there we have a really easy way of remembering those exact values. We use our hand, the special angles 0, 30, 45, 60 and 90, and just remember for sine and cos it's root fingers divided by 2. Sine is root fingers below the bent finger and cos is root finger above the bent finger. And for tan, you just flip it over and it's root fingers divided by root fingers.
One thing I would say about that last one is when you do root fingers over root fingers, you need to rationalize if you have a radical in the denominator. So I think on that one, they had 1 over the square root of 3. So you'd have to multiply the top and bottom by the square root of 3. So that's a nice little trick. So whenever you're trying to buy 30, 45, 60, those triangles are those angle measures. And remember, whenever you're trying to find reference angles, they're all based off of that. You just have to know which quadrant it is. So whether you know sine is positive or cosine is negative or whatever it is. So all students take calculus. Again, in the previous lesson, all students take calculus. Okay, so that's really not what I was getting into, but because we had the table on the last lesson, I wanted to kind of show you a trick with and that video does a really good job of it. So what we're going to do today is arc length of a circle and area of a circle, or area of a sector of a circle. Now, of course, we know that area of a circle is pi r squared. But when we're talking about a sector of it, a sector is just this little area. So we need to know what that area is. And then, of course, arc length is going to be from here to here. So kind of developed this idea. So the length here, kind of did it a little bit on the previous lesson, but when we start talking about radian measure, but I'm going to do it a little bit better now. So remember that one radian is going to be, the arc length is going to be the same as the radius. So if we have a circle and you have the radius, and we talk about 1 radian, you know, that's not in degrees, it's 1 radian. So 1 radian, this arc length from here over to here is the same as this radius. So of course, there's 3.14 or pi radians in 180 degree arc. Okay, so let's just go back here and say 1 radian is equal to 1 radius, which is the arc length. And we have this proportion that could be stated. So S is the length, the arc length. So let me define things. S is the arc length. R is radius, of course. And theta is in radians. Very important that it's in radians. So S is to R as theta is to 1. So what I have here is a picture. And you're going to see that this S is to this R as 1, because this is 1 radian right over here, is to S is to R is to this theta measure. So it's kind of like a nice proportion here. So S is to R. I should have used a lowercase r. Whoa. Sorry, clear. That's wrong. S is to R, this length, as this is to this. So just making sure that you put them in the same proportion. So you're talking about S over theta, or S is the same as theta, and S over R and theta over 1, because the radius is 1, or the radian is 1 over on the blue one. So the red one, comparing it to the blue angle. When we solve this by cross multiplying, we're going to get S is equal to R theta. And that formula needs to be memorized and understood, because that's going to always give you the arc length. And this happens a lot on SAT tests, but they're not going to give you that formula. So you have to memorize this one. The other thing to keep in mind is that theta, whatever theta is, has to be in radian measure. So you can't use degrees. So circle has a theta measure. A circle has a radius of 25.60 centimeters. And all we have to do is multiply by 7 pi over 8. Now, when you're doing that, just go ahead and multiply 25.60 times 7 times pi, and then divide it by 8. And that's the easiest way. And you'll get a value of 70.37. Now, notice in my problem, I put 22.4 pi. A lot of times they will write stuff in terms of pi, so just want to keep that in mind as you're doing these problems. Now on 54 degrees, we'd have to change it to radians. So let's make it easy on ourselves. We know that we have to multiply by pi over 180. So just think of this as 54 pi over 180. If you want to simplify it, great, but you don't have to. We have calculators, so we can just multiply straight across 25.6 times 54 times pi, and then divide it by 180. And we'll get 24.13. I rounded it to the hundreds place. So 24.3, and this is in centimeters because this is in centimeters. So I should probably use the units. Now you're going to notice when I did it here, I simplified that to 3/10, knowing that 54 has 6 in it, or 54, well, it's 54 divided by 3. 18 goes into both of those numbers. So I'll erase this. But they reduced it to 3 pi over 10. But there's no reason to have to do that. We can do it with just taking 25.6 times 54 pi all over 180 and getting your answer. Okay. Just want to point that out because sometimes we think we need to do something crazy with it. Okay, so latitudes, remember lat is flat, longitudinal lines are long, lat is flat. We're talking about from Erie, Pennsylvania to Columbia, South Carolina. The latitude of Erie is at 42 degrees north latitude, and the Columbia is 34 degrees north latitude. We want to know what the distance between these, because the Earth is round, so we know to know the distance from north to south. If you're flying like in a plane or you're walking on the ground, but you're going directly north and south. So here's the Earth. It's pretty ugly. What does this say? Columbia is at 40, or Erie is at 42, and Columbia is 34 degrees. Now, we have to know a few things here. We have to know that the Earth has a radius of 6,400 kilometers. And we're going to keep it in units of kilometers, but we could look up what miles were if we wanted to. Now, when we're talking about, let me go back, from the center of the circle to the edge, and I know this is, well, maybe I should have put them right here and here. It might have been easier to see. So this is 34 and this is 42. It'll be easier to see. Let me erase this. Okay. From the center of the Earth, this is the center, from here over to here, we're trying to figure out what this distance is. We know that the difference between these is 8 degrees. So when you subtract those two, you get 8 degrees. So S is equal to R theta. So we'll take R radius, which is 6,400 kilometers, multiplied by 8 times pi all over 180. Because remember, we were having to change this to radian measure because we can't use degrees. So 6,400 times 8 times pi divided by 180 is 893.6 kilometers. So that's how many kilometers are between the two, approximately. Now they've rounded their answer to 890 kilometers because I guess they wanted it to 2 decimal place, or basically rounding it to the 10th place. A little hard to, be exact with those when our measurements are only 8% or 8 degrees. That's not very accurate when we're talking about something really big. So I love this question because I like to say it. A rope is being wound around a drum with the radius of 0.327 meters. How much rope would be wound around the drum if the drum was rotated around an angle of 32.6 degrees? When I do it, I always have to put that accent there. A rope is being wound around a drum with a radius of 0.32 meters, 27 meters, and how much rope would be wound around the drum? if it was rotated 132.6 degrees. So what happens is we start the rope here, and we're going to rotate this barrel or drum. I guess this is a drum, but you might think of it as a barrel. And we're going to try to figure out what this distance is. So we've rotated at 132. Now this kind of is misleading. This is 132.6 degrees. Over there, it doesn't look right. Okay, so when we rotate it, or I guess rotate it this way. So anyway, we need to use S equals R theta. That's all we have to do. So radius is 0.327 meters. Didn't need to put that meters. And then we're going to multiply it by 132.6 and then pi over 180. Again, trying to make it as easy as possible. This number is in the decimal point, so we want to make sure our answers are in decimals. So if it was like 1 meter, we could probably round it to the nearest meter, but let's make it easy on ourselves. So I'm just multiplying all those numerators out. So this times pi. And dividing that by 180. I get 0.757. I'm rounded it to hundreds place. Reason I'm rounding it to hundreds place, this has 3 decimal places. So that's how long it is from here over to here. Again, remember this formula that you're memorizing for the ACT, SATs, and all the other classes you're going to take. Make sure you put it into ready measure. So same answer as them. Let me erase this clear. So let's say we had 2 gears and they're adjusted. So the smaller gear drives the larger gear, and the radius of the gears are 3.6 and 5.4. And the smaller gear rotates through 150 degrees. So as this one rotates, this gear is gonna, what are you talking about, gears? Okay, that's what I'm talking about. So we have the small gear, and it's gonna rotate 150, and then we'll have the large gear, and it's not gonna rotate as much because it's a smaller gear, but they touch each other on edges. So that if this arc and this arc, they're going to touch the same amount of length because the cogs go. But the smaller gear is going to go a lot more. The bigger gear is going to go less. With a bicycle, because I ride bikes, usually, well, the bigger gear, you're cranking this big gear, and it's making the small back gear move faster. So kind of the same idea. It's going to rotate it many, many, many times and make that wheel go around many, many times. So kind of the idea. So when we start to do this one, what we probably need to do is figure out what radians are of 150 degrees, which that's what we did. And we need to figure out what the distance that the small gear goes. So you could have done this with 150 over 180, and you would have got 3.6 times. And they got 3 pi, so they left the pi in the answer. Sometimes that happens. That's fine, whatever. So you just have to, worry a little bit about that. But 3.6 times 5 divided by 180 is 3, or divided by 6, I'm sorry. So 150, because they reduced this and it's reducible, times 3.6 divided by 180, they get 3 and 3 pi. So that's how long the distance this one turns. So this one's going to turn the same amount of distance. So what we need to do is rewrite the formula and say 3 pi, or we could put the decimal answer of that. And we also know that the radius of the second angle is what is it? 5.4. But we don't know how much it's going to rotate. So we're going to divide both sides by 5.4. And we'll get theta is equal to, so 3 pi divide, come on, 3 pi divided by, oh, okay, we need to talk about something. Oh, no, we don't have to. 3 pi divided by, I was thinking order operations there. I might want to find 3 times 3.14 and then divide by 5.4. But anyway, we get radians of being 1.745. Now I'm leaving that in my calculator with all the decimals because I need to know how many degrees this is. So we have to take this answer and multiply it by 180 over pi. So we're going to multiply that by 180 and divide that by pi. And we get 100 degrees. Now, if you round it off, you may not get exactly 100 degrees. So the little gear moved 150 degrees. The small gear or the large gear moved 100 degrees. So a little bit different as we go at. So here's my answer kind of written out with that problem. So there's a lot of these where you have two gears that they're kind of working together. So, okay, so the second idea is area of a sector. And the formula for area of a sector is 1/2 r squared theta. But we know the area of a circle is pi r squared. So there has to be some kind of tie in between the two. What we have is, if you think of a circle, a complete circle, that is going to be, a complete circle is going to have a rotation of 2 pi. So if we were to use this formula, 1/2 the radius squared times theta, which is 2 pi, you notice that the 2's cancel and we're left with r squared pi. And we know that as pi r squared. So this formula that you learned back in grade school or middle school, you used and you were happy about it, but this was the original formula. And it was able to figure out the area of a sector of this degree measure. Now, again, you need to change your degrees to radians. So let me get my pen working. 1/2 the radius, which is 15.2 squared times theta. And theta is going to be 108. 108. Mr. Beatles, not 180. Oh, I erased it all. Oh, I can bring it back. Okay, there it is. I forgot it should be 108. Okay, times, I got all lost on what I was doing, times pi over 180. So you got to be careful when you're multiplying all this out. I would suggest you take 15.2 and square it times 108 times pi, and then divide that by 360. So 15.2 squared times 108 times pi, and then divide that by 360, and you get 217.75 feet squared. Now I'm being accurate to 3 decimal places, or I guess, yeah, well, to 1 decimal place and 1 decimal place here. So we probably should be 1 decimal place with this one also. So 217.8 feet squared. And that's what I got it with the red number. So this area. So you always need to have this formula, and this one's a really good one to memorize too. Again, when you're taking the AccuPlacer, when this won't be on the AccuPlacer, but unless you're taking an advanced test of AccuPlacer. But if you are taking the SAT, you have to know this formula. You can't just, oh, they're going to give it to me. Sometimes they give you formulas somewhere and you have to go look for them, and maybe you'll know what this is, but S equals R theta. Theta is always got to be in